Good afternoon, students. Today our topic is discrete energy exchanged by atoms and Frank and Hertz experiment. Okay, so today we will discuss Frank and Hertz experiment. So first of all, we should know what is the purpose of this experiment. Okay, so what is the main purpose of this Frank Hertz experiment? So here, according to Bohr's model, the atomic energy levels are quantized. Okay, so according to Bohr's, we have different atomic models: Bohr's model, Thomson model, Rutherford model, Sommerfeld model. Okay, so in this way we have different atomic models. So actually, what it means, what is the meaning of atomic model? So any atomic model gives the information about the atoms. Okay, it gives the information about the internal structure of the atom. Okay, so according to Bohr, so Bohr said that atomic energy levels are quantized. So what is the meaning of quantization? Quantized is nothing but perfect energy levels, exact energy levels. Okay, if you take atom like this, so this is atom, so centrally nucleus. Okay, okay, so this is atom, centrally nucleus, like this. So electrons are moving around the nucleus. Okay, so these traveling path we call as the orbit or orbital or energy levels. So Bohr is a scientist. He said that electrons are moving a particular energy levels only. Okay, so electrons are moved. This is the nucleus. So particular energy levels only. So the energy of these levels are quantized, perfect. Okay, so I mean the energy of these energy levels contain constant values. That is the meaning of quantization. Okay, so this orbital have some energy, this one is different energy, this one is a different energy. I mean, so this orbit have some constant energies. Okay, it maintains some energy. So this one maintains some energy. So I mean these orbitals maintain some energies, perfect energy levels or constant energy levels. So this is the meaning of quantization. Okay, na? So this is the meaning of quantization. So here this is a theoretical concept. So the practical evidence. So this Frank and Hertz experiment. This is a practical evidence of the quantization of energy levels. Okay, so this is a practically proved that so discrete states for electrons in atoms. Okay, so he said that electrons have some discrete states. Okay, so this is experimentally proved by this Frank and Hertz experiment. Okay, so we'll enter the experiment. Okay, so here mainly what is the principle of this experiment? So the principle of this experiment is nothing but it consists passing the accelerated electrons in the gases and vapor and study measuring in resulting current. Okay, so when electrons are moving in the vapor or gases, we will measure the current value. Okay, this is a main principle of this experiment. Okay, next we will plot the accelerated potential and with electrons with current. Okay, we will plot some diagram with we will plot one graph. So according first we take the current versus potential. So in this graph it shows that some discontinuous at potentials. Okay, so next I will explain. First we will see the operators. So first we will see the experiment. So after that I will discuss about the discontinuous in the curves. Okay, so first, so this is a apparatus scientific diagram of the Frank Hertz experiments. So first one, this enclosed tube. This one is a tube represented by T. This enclosed tube is consisting of filament, okay, and a grid and a plate. Okay, and this plate is connected to some millimeter, sensitive millimeter, and so this one is connected with retarded potential. Okay, so this one is another potential. Okay, so this one is grid potential. VA is nothing but a grid potential. So here by using this rheostat and batteries, when we apply filament is nothing but when we apply some current to this filament, automatically this filament produce the electron. Okay, the job of the filament to produce the electrons. So this tube is contain some atoms or some gas. Okay, so the atoms under study, or this tube contains some gas molecules or vapor. Okay, so when these electrons are passing or producing from the filament, so these electrons are moved through this tube. Okay, so here, so automatically some collisions are taking place between electrons and atoms. Okay, collisions are taking place between electrons and atoms in the tube. Okay, and next one, so here this is a grid. The distance between grid and plate is very small, and so this is a positive plate. Okay, this one is a positive plate. So automatically when we when we increase the potential of this positive plate, automatically the speed, the electron speed are increases. Why? What is the reason? Nothing but, so electrons has a negative charge. Okay, so this one is a positive plate, has positive charge. So automatically attraction force taking place between electrons and this positive plate. So automatically electrons are moving with very speed towards the plate. Okay, so here, so we are but some retarded potential is present at the G grid. Okay, this retarded potential oppose the or stop the flowing of electrons. Okay, or this grid oppose the moving of electrons. Okay, so but some electrons only high energetic electrons only overcome this grid retarded potential and reach the plate. Okay, reach the plate. First we see this diagram. This is IP. Okay, plate current. So this one is the so potential, grid potential. VA is the grid potential. So VC we call as a critical potential. Okay, na? So VC is called as a critical potential. So here when the electrons are moving, when we increase the grid potential, automatically electrons are moving with very speed. Okay, so very speed and reach the plate. When it reaches the plate, automatically the current of this plate increases. So that this line is increases. Okay, ఇక్కడ line ఎందుకు మనకి ఇక్కడ increase అయింది అంటే, so number of electrons are reached this plate, so that this line increases. This OA represent that one, and here the elastic collision is taking place. Okay, so here in between electrons and atoms, elastic and inelastic collisions are taking place. What is the meaning of elastic and inelastic collisions? If you take like this, these are the atoms. When collisions are taking place in between elastic, so here the total energy is same. In elastic collision, the total energy velocity is same. Okay, so here, or if inelastic collision taking place, the total energy of the system is not same, the velocity also not same. So whenever the collision taking place, automatically energy is automatically lost. Okay, where the collisions are taking place, automatically energy is lost. But in the case of elastic collision, the energy is not losses. The energy is not losses. But in the case of inelastic collision, the energy losses. Collisions nothing but like accidents. Automatically inelastic collisions, the energy losses. Okay, so when we apply, when we increase the potential of this plate, automatically some elastic collisions taking place and number of electrons are reached this plate. So the current of this plate is increases like this. Okay, after that number of inelastic collisions taking place between electrons and atoms. Okay, so automatically the energy losses, so that these electrons are not unable to reach this plate. Okay, these electrons are unable to reach this plate, so that the curve drops sharply. Okay, the curve drops sharply. In this way, when electrons are only excitation taking place, going to higher places, but the total energy is losses, so that this curve AB drops very sharply. Okay, next time further we increase the potential of this plate, automatically the positive potential increases, number of electrons are move very fastly towards the plate P. Okay, so automatically when these electrons are moved towards this plate, current IP increases. So this BC curve represents like this. Okay, this BC curve represents here in inelastic collision is taking place. So in the case of inelastic collision, there is no energy loss, but number of electrons are moved towards the plate P, then automatically current IP increases. Okay, so this BC curve represents this situation. Automatically next CD situation, CD curve represents when after that some inelastic collision is taking place, so the total energy automatically losses decreases. So automatically when energy losses, the electrons are unable to reach the plate P, so automatically the current IP decreases. Okay, so this curve drops very sharply. So this is a process when elastic collision is taking place, so and automatically the number of electrons are moved this point, then the total current increases. When inelastic collision taking place, the current is decreases. Okay, this is the reason. So according to by this experiment, we concluded that electrons or atoms accept a particular energy levels only. These are the energy levels. Okay, the electrons or atoms accept particular energy levels only. This is the first energy level, this one is second energy level. Okay, there is energy gap between first energy level and the second or third energy levels. So from this we concluded that so atoms or electrons have stationary orbits or discrete energy levels, or the energy levels of the electrons are quantized. Okay, so this is the first energy level, second energy level, third. So the energy levels of electrons are quantized. Okay, so and next thing is, so in this Frank and Hertz experiment we used mercury vapors. Okay, mercury is represented by Hg. So mercury represented by Hg. So Hg here we use this mercury vapors. So the potentials of this mercury vapor, critical potential 4.86 or 6.7, 6.67 or 8.84 or 10.4. Okay, so here next thing is, so this the peaks, the in between two peaks, so this is a critical potential. Vc is called as a critical potential. I mean electrons are reached maximum velocity, then this potential we call as the critical potential. So here these peaks we call as a critical potential, Vc and 2Vc, 3Vc. Okay, so this one is called as a critical potential. So this is the information about the Frank and Hertz experiment. Thank you.